Hey, welcome to lesson 3.6, corresponding parts of congruent triangles. In this lesson, we're going to continue what we learned in our last lesson about proofs with an added little twist. And we're going to be learning about two more essential theorems that we need to be a master at proving triangles are congruent. Alright, so first we're going to talk about those two theorems, then we're going to talk about what this thing is, corresponding parts of congruent triangles. So what are these two new theorems that we're going to be using to prove triangles are congruent? Well, before we start, I want to list the ones that we already know. Let's make a little list of the theorems we know to prove triangles are congruent. One, we know vertical angles, the vertical angle theorem, right? Two, we also know the reflexive property. Three, we know the midpoint. All right. And four, we know perpendicular theorem. All right. These four theorems we already know. We're going to add two more. The first one is the segment bisector theorem. And this is our key word here. Bisector, all right, anything that bisects means to cut into two congruent pieces. Or another way to say that is it's to cut it in half. You have to cut it in half, okay? Cut in half. That's what bisect means. So a segment bisector, well, this is our theorem, a segment bisector divides a line into two congruent parts, which makes sense. Let's take a look at how this would be used. Well, our statement here is AE bisects BC. All right, so AE, which is this line right here, bisects BC. And what that is saying is AE cuts in half BC. So AE cuts BC in half, all right? Cuts in half. So if AE cuts BC in half, well then I know that it splits into two congruent parts. So E is our midpoint. It's basically the same thing as the midpoint theorem, right? Cuts it right in half. So our conclusion would be BE is congruent to EC. So a segment bisector just cuts a line in half. All right, the way I like to think of it is that AE, the first one, is your knife that's doing the cutting. All right, and your BC is your bread. And that's being cut in half, right? So cut in half like a bread sandwich. Anyway, okay, I'm just going to keep going. So angle bisector theorem is very similar. So an angle bisector would probably be something that cuts an angle in half. Well, let's look at the theorem. An angle bisector divides an angle into two congruent parts. All right, so it's just like the same thing, but instead of cutting a segment, we're going to cut an angle in half. So here our statement is YX, that should say YW bisects angle Y. Sorry about that. YW bisects W. So this bisects our angle Y, which is right here. And what that means is that it takes angle Y and it cuts it into two congruent pieces. So I have these two congruent parts right here. So whenever you have a line that bisects an angle, it cuts it into two congruent parts. So now I know that angle XYW, that's this angle right here, XYW, is congruent to angle ZYW. So you cut angle Y in two parts, so it's ZYW. So it just cuts an angle in half. That's all an angle bisector does. Cuts angle in half. The real key thing here is marking it. So if this line cuts this angle in half, make sure you know how to put your marks there. All right, let's use this for proofs. So given AC is congruent to CB, CD bisects AB, and we want to prove that ADC is congruent to ADC. Now remember, the first thing we're going to do, step one, is to mark everything. All right, so we know AC is congruent to CB. We know CD bisects AB, so this is our knife, right? And it's cutting our bread in half, which is AB. So I know that this part is congruent to this part, because that is our midpoint. And then finally, though it doesn't say it, I know that the reflexive property is at play here, because they both share a side right here. So let's mark our shared side. Oh, should probably put that. So let me get this out of your way, and let's just mark this properly. All right. So mark, shared side, and we know that these are congruent. Okay. Well, now it looks like we have side-side congruence, which is great. So now all we have to do is do our little proof. So we draw our T-chart. We write evidence, all right, and reason. And let's just start writing what we know. 1, I know that AC is congruent to CB. All right. I know that AD is congruent to DB. All right. And I know CD is congruent to CD. All right. And that's just this line's congruent to itself. All right. Let's write out our reasons. How do we know all these things? Well, I know AC is congruent to CB because it's given. All right. That's 1. Oh, don't forget your numbers. All right. I know AD is congruent to DB because the bisector theorem, segment bisector theorem. Now remember, I'm not writing out the whole thing, but you can't write segment bisector theorem. You have to write this: a segment bisectors divides a line into 2 congruent parts. All right. I don't have the space to put that there, but that's what should go right here. You got to write the whole thing. And 3, CD is congruent to CD. That is the reflexive property. Reflexive. All right. Now we have our proof. We know that triangle ADC is congruent to triangle BDC because of side, side, side. All right, let's try it one more time. In this case, we know angle G is congruent to angle I. Let's mark it. Angle G is congruent to angle I. And we know FH bisects GFI. That's this angle right here. So FH, which is our line right here, bisects this angle right here. So what I'm going to mark is these 2 angles, right? FH is cutting this angle in half. All right? Take a minute, pause. If that's not making sense, just highlight your angle and your bisector. And that will show you that these 2, it cuts this angle in half. All right, pause it if you need to. Feel comfortable with it. It's cool. Now the final part here, I see that they both share a side right here, so I'm going to mark this shared side in the middle. So I'm trying to prove that these 2 triangles, GFH and triangle IFH, are congruent. It looks like we have angle, angle, side here. So we did it. Great job. Let's just write our proof out. This is the annoying part, huh? So we have our evidence, and we have our reason. So let's start off. What do we know? 1, we know angle G is congruent to angle I. 2, I know angle GFH is congruent. That's GFH is congruent to HFI angle. And 3, I know FH is congruent to FH. All right, now let's just write our reasons out. Well, G is congruent to I, that is a given. That was given to us. 2, GFH is congruent to HFI. Well, we know these, it's cut in half because of the angle bisector. And I'm going to keep saying this. I don't have the room to put this in there, but you should write this whole thing. An angle bisector divides an angle into 2 congruent parts. That's how you know this is true. You can't just write the theorem. And 3, we have our shared side. This is the reflexive property. All right, so what do we know? Our conclusion is triangle GFH is congruent to triangle IFH. And that is ASA. All right, we're rocking. Let's learn about this Cpctc thing, okay? And what this stands for, Cpctc, you'll get used to this, is corresponding parts of congruent triangles are congruent. Now, why do we even need to know that, okay? Well, first of all, you already know this. You know that the corresponding parts of congruent triangles are congruent, meaning that if 2 triangles are congruent, you know A is congruent to D, B is congruent to E, C is congruent to F, and all the sides are congruent. You know that. That's true. All right? But how are we going to use this now? Well, some proofs tell you to say that when 2 triangles are congruent. But other times you might be asked to prove that, well, let's see, is AB congruent to DE? All right? And it's not marked. Well, to prove that, you have to do two things. You have to do exactly what we've been doing. First, you have to prove that the triangles are congruent. All right, first you prove that triangles are congruent. So right here, I know they're congruent because it's side, angle, side. All right, so now that I know they're congruent, then I know that AB must be congruent to DE because congruent parts of congruent triangles are congruent. If you need to rewatch that, do that. Like I said, this might be a little confusing, but I'm going to say this again. If a question is asking you to prove that AB is congruent to DE and it's not marked, the first thing you do is prove the triangles are congruent. And if you know the triangles are congruent, then you know that each side is going to be congruent. All right, let's take a look at this in action. All right, for our first one, we know that AC is perpendicular to BD. Let's mark that down. And I know AB is congruent to BC. Let's mark that down. All right. I'm trying to prove that AD is congruent to CD. Now to do this, all right, to prove that these are congruent, first we're going to do exactly what we've been doing. We're going to prove the triangles are congruent. And if I know those two triangles are congruent here, ABD is congruent to CBD, then I know that AD must be congruent to CD. So we're going to start by proving the triangles are congruent. All right? Well, right now we know we have two pieces of information. There's one more we have to mark right here. It's a shared side. All right? So you can see here that the two triangles are congruent. We have side, angle, side congruence. But now we have to write our proof. So let's show how we're going to do this. We have our evidence. All right? And we have our reasons. All right. Let's write out the evidence that we have. We know AC. Oh, sorry. We know AB is congruent to BC. Okay. We know angle ABD is congruent to angle CBD. You see here, that's these two angles. Those two angles are congruent. And I know side BD is congruent to BD. Okay, so that's our evidence. Now let's write our reasons out. Well, we know AB is congruent to BC because that's given. Okay, we know angle ABD is congruent to CBD because of the perpendicular angle theorem. Once again, you should be writing out the whole thing. I don't have the room to do it because of this weird marker I use. And BD is congruent to BD because of the reflexive property. And you should write out the whole thing here. Now that we have our information, we know that triangle ABD is congruent to CBD. And why do we know that? Well, we know that because of side, angle, side congruence. Now that I know the two triangles are congruent, to prove these are, you just have to add one more line, and this is it. I know that AD is congruent to CD, and the reason I know that is because of CPC, corresponding parts of congruent triangles are congruent. And you could actually just write this abbreviation. You have to write the whole thing. Cpctc. Corresponding parts of congruent triangles are congruent. If these two triangles are congruent, then these must be congruent to each other. All right? And that's it. So this is what Cpctc is, that extra line that you have to add after proving they're congruent to show that two sides or angles are congruent. Let's try it one more time. In this case, we know angle BCA, which is right here, is congruent to angle DCE. All right? Feel free to pause. I know I'm rushing a little, but figure out how I'm marking these angles. I also know that angle B and angle D are right angles. Finally, C is the midpoint of BD. So if C is the midpoint, then I know BC is congruent to CD. I want to prove that BA, this line right here, all right, is congruent to DE. Well, we've done a great job marking because we could see that these two triangles are congruent because of angle, side, angle. So now we just have to write our proof, all right? That's the annoying part, I know, stop moaning. Let's just do it. We have our evidence and our reason. And once we prove that these two triangles are congruent, well, then I know that BA must be congruent to DE because of Cpctc. So 1, what do we know? I know angle BCA is congruent to angle DCE. 2, I know angle B is congruent to angle D. 3, I know BC is congruent to CD. And 4, oh, we're not there yet. All right, so now we're just going to write our reasons. Well, the first one was given to us. Thank you very much. Our second one is that right angles are congruent. Angles are congruent. This is the perpendicular angle theorem. And BC is congruent to CD. Well, that's because of the midpoint theorem, right? And we knew that C was our midpoint, so we knew BC is congruent to CD. So this was our midpoint theorem. And write out the whole thing. Now that we got that, we just have to write out our proof. So I know triangle ABC is congruent to triangle EDC, and that's because of angle, side, angle. And finally, to make our proof final, I know that BA is congruent to DE because the reason is Cpctc. Corresponding parts of congruent triangles are congruent. All right, if these two triangles are congruent, then D must be congruent to AB. All right, that's it for this lesson. Remember, guys, don't maybe, no, do. I'm going to start with a do. Do tell someone you love them today and do something nice because it's all about positive energy. Remember, I'm not just your math teacher. I'm also your life teacher. Goodbye.